In today's production environments, operators face growing pressure to work faster, safer, and smarter. And with that in mind, reimagining prep and column changeover workflows can unlock new levels of productivity, reduce risk, and empower production teams to do their best work. I'm Miles Skoda. This is the bioprocessonline.com virtual event series, and today we're talking just that, driving operator safety and process efficiency through innovative prep and column changeover. Now, joining me for this presentation is an industry expert from Asahi Kasei, column engineering lead Liam Takahashi, who is going to look at the strategic importance of safety and efficiency and increasing overall operational productivity. He'll discuss how to challenge conventional approaches to column preparation and changeover and show tools that can enable more efficiency within pharmaceutical production while increasing safety for operators. We will be holding a Q&A session following this presentation. Please feel free to submit questions as we go along. We'll get to as many as possible during that Q&A, and any that we don't get to, I'll pass along to the team for potential follow-up after the event. And then just a bit of housekeeping. If you run into any issues today, please try refreshing your browser first. If your problem persists, you can submit a question through that Q&A, and I'll help get you back on track. And then finally, this event will be available on demand, usually within a day, often much less. You'll get an email with a link to it, or you can just use the same link that you used today. So with all that said, let me turn it over to Liam to get started. Liam?
Yeah, thank you for that introduction, and welcome everybody for joining today. As you stated, my name is Liam Takahashi. I am a column engineering lead at Asahi Kasei Bioprocess, and today I'll be talking about driving process efficiency and safety through innovative prep and changeover, specifically in chromatography and oligonucleotide synthesis columns. So, a little bit about what I'm going to be talking today, a little bit about Asahi Kasei Bioprocess as a company, what current challenges we're facing, why change is needed, what Asahi has come up with for solutions, and a little bit of wrap up and questions at the end. So, about Asahi Kasei Bioprocess. So, Asahi Kasei Bioprocess Division, the fluid management business unit, is devoted to solving therapeutic product safety, efficiency, and purity challenges within the pharmaceutical and bioprocess industries. We strive to be a trusted advisor to our clients by providing custom and standard equipment for tomorrow's manufacturing today. So within Asahi Kasei Bioprocess, we have different business units. Some of the platforms that we excel at are virus filtration, oligonucleotide synthesis, inline buffer formulation, chromatography, bioprocess systems, columns, automated solutions, as well as biosafety testing, manufacturing. But today we'll be focusing on the fluid management division with the chromatography and synthesis columns. A little bit about our geographic location. We're located all throughout the world. And we provide, sales and assistance throughout the world. But our headquarters are located in Glenview, Illinois, just north of Chicago. Here we do the engineering, design, development, assembly, science and technology, quality, and some demos and testing as well there. And we are very committed to quality at Asahi Kasei Bioprocess. We sustain our ISO 9001 certification. We pride ourselves in our high customer satisfaction levels, continuous improvement, and our company values of sincerity, challenge, creativity, wisdom, curiosity, growth, passion, and responsibility. So, what are some of the current challenges we're seeing today? One of the biggest challenges that we see today, hold on a second. There's a lot of notes. I have to expand it, so I'm going to try this.
Gotcha. All good.
Okay, safety is companies' usually the number one priority when talking about the using of large columns. And within that large part, handling is a big issue, and liquid and dust handling and exposure are a lot of things that are talked about. When you're talking about smaller or medium-sized equipment, Some parts can be lifted manually. It's still a little cumbersome because you're doing it manually and you're gowned up in a clean room with gloves and masks, which can make things even more cumbersome and harder to see. And lifting and swinging these parts around can cause damage to operators and people or parts in the room. And depending on how large these parts are, you might also need special rigging or equipment to lift these. And depending on how these are rigged together, there are hazards of dropping these parts. And a lot of times in the safety rooms, you have to wear safety shoes. And a lot of people joke that the reason they have safety shoes is because they oftentimes drop bolts or wrenches on their toes, not for big things. So even small parts like that, when disassembling the columns, can be hazardous. Another thing is liquid and dust handling and exposure. So one of the first steps in getting a synthesis or chromatography column ready is to charge it full of media or solid support. Most of the time it comes either in a powdered format or semi-liquidous format already that you maybe add more liquid to, and you have to mix it up manually. On the smaller scales, you just mix it in some sort of container, maybe by shaking it or in some sort of vat and stirring it. But as you scale up, you'll have to lift heavier things. I know some people who've even rolled them on the ground trying to mix it up, or even a bigger vat, which can expose you to more dust and chemicals, especially if it's in a powdered format. And so this exposure can lead to, harm to your lungs, or, any exposure to your skin as well. And when you're packing the column, you also maybe have to lift it up to pour it into the column, and having it up at chest height can also lead to, splashes to the eye or the face, which is a big no-go, and we want to make sure that everybody is safe. So kind of in line with safety is ergonomics. So we talked about lifting heavy containers and carboys and repetitive. There's also repetitive motion that's involved. If you have columns unpacking with bolts, you're underneath a column that's also cumbersome to get underneath the column or maybe on top of the column, depending on which brand of column you're working with. But you're often put into tight locations or not ideal locations, and you're with a wrench repetitively trying to undo some bolts, or with your hand trying to unscrew in uncomfortable situations. And again, when you're doing this, you're all in your gown, beard net for myself, hair net, safety glasses, and mask. And oftentimes your goggles get fogged up and it's hard to see things, making it even more of a dangerous situation, either than needing to take off the glasses or working with limited visibility. And this is the same for maintenance. When you do maintenance, same thing, working with bolts, maybe in not so ideal positions as well. So one of the most quantifiable challenges that we see is the inefficiencies in the downtime of these columns. So by downtime, I don't mean, when columns are sitting off to the side and not anything being done on them. What I'm referring to is the packing, unpacking, cleaning, disassembly, and maintenance times that it takes between your batches that is costing you time and money. So with the packing and unpacking, I sort of discussed it. You might be underneath the column with wrenches and bolts, taking a couple people, depending on how big the columns are. You might be a couple people taking a couple hours or a couple days to unpack the column and do disassembly. And the maintenance, most of the time, maintenance isn't a huge issue if it's the planned maintenance, because you can plan it on company downtime or when you don't need to be doing any manufacturing. But the big killer here is the unplanned maintenance. That's either caused by poor planned maintenance in the past, or it could be caused by damage due to misuse and not keeping, spare parts and inventory that you need on hand. And this usually happens at the most inopportune time, either during a batch or at the start of the batch is when you finally realize that something is going wrong. So, why is change necessary? Well, we're talking about the downtime, and the downtime between batches costs the company a lot of time and money. So the disassembling, cleaning, reassembly, all that preparation, packing and unpacking the column takes a lot of time, manpower. Like I was saying, it can take people maybe 2 to 5 days, depending on who is available, what type of workers are available, if they're trained on doing this or not, and doing maintenance, whether that be planned or unplanned maintenance, can cost a lot of time. And we actually surveyed some of our customers to figure out how much each column's time is worth, or what the loss downtime is worth. And more of them that we surveyed said about $10,000 an hour or $80,000 a shift, which makes it almost $250,000 a day for lost time if you're running 3 shifts in a day. So that is a lot of money. At least for me, it's a lot of money. I don't know about for you guys, but because all the stuff costs so much money, you want to be working it to the full extent and getting your money's worth out of it. Another thing is lost batches. We don't want to see this ever happening, but if there's not proper use or damage to the column, things are leaking, maybe something catastrophically fails, you can lose your batch. And in a similar survey, we talked to a customer using a 50 centimeter synthesis column and a 60 centimeter chromatography column to see at the different stages how much that batch would actually cost them. And after the synthesis step, it would be worth around $1 to $3.5 million, and after the chromatography step, around $3 to $5 million. So that's significantly more time. It's less likely to occur, but still, it is something. This cost of this changeover and downtime can become exponentially expensive, depending on how severe the problem is. And we talked about safety and ergonomics. So that leans into personnel. So personnel, the safety and ergonomics can lead to personnel turnover and some training issues for if it's difficult to operate, or fatigue and injury, depending on what types of columns you have. So employee turnover, I see a lot of turnover in this industry. It might not be due to personal or company reasons. It might just be due to people being promoted. A lot of times people start as an operator level and then they get promoted very quickly. Or it can be due to employees leaving for other companies for better opportunities. And this turnover, you have to train all these new people. And some people who are coming in often are chemical engineers who might lack mechanical mindsets on how to operate and do maintenance on these types of equipment, where everything's held together with bolts and nuts, things like that. And when you're training these new hires, it often becomes a game of telephone where, let's say somebody from Asahi trains somebody, that person gets promoted and they need to train somebody else, and then they need to train somebody else. And by the time the newest people are there, it's something for lost in translation down the line. And oftentimes there's very infrequent training. Time is money, like I was saying before, and people want to be spending it on doing the process. And training is important, but a lot of people want to focus on doing the process, making the money. But I use a saying, slow is smooth and smooth is fast. I think it's started as a racing term. Instead of trying to rush through things, you do it slow and right the first time, and then you won't have to come back and fix it later on. So having proper training, frequent trainings, so that we don't see these errors, and like I was talking about, downtime due to unplanned maintenance is probably one of the biggest killers. And by having trained people, it makes things less likely to happen. And fatigue and injury, kind of talked about that during the safety. So, we need to make sure that people are safe, people are comfortable while working, especially in these clean rooms when you got extra clothes, extra glasses, masks, hairnets, things like that. So, what has the Asahi Kasei done to, solve some of these problems? Well, to show you what we've done so far, I thought I'd show you what we have and what a lot of people have in the past for chromatography and synthesis columns. So here's some of our, flagship chromatography and synthesis columns. The synthesis is the SCS column, static compression synthesis. And our DAC columns, dynamic axial compression, is our chromatography column. And as you can see here, they're stainless steel vessels. For the synthesis, there are held together with the bolts on the top, the long bolts that actuate the top plate from going up and down, making it be able to go to any bed height that you need. And once it's there, you fix it in place with the nuts. And it allows for the synthesis process, the solid support, to shrink and expand to the bed height needed. While the DAC column has a movable hydraulic piston inside that can compress the resin or silica for the purification process. And the moving piston allows you to adapt to keep the bed packed at constant pressure. And everything is held together with bolts, as you can see on the bottom and the top of the column. There's bolts holding two plates in place. So one of the first things that we came out with a couple years ago was the DAC ergo column. So it's the dynamic axial compression, or chromatography column, but ergo for ergonomic. So the DAC ergo, the column on the inside doesn't look that much different. The operation of the column in its regular state is the same. One thing that you can see is different is that the frame holding it together looks different. And then if you can look at the bottom of the main tube, you see these eye bars. So the bottom plate is actually held together with the eye bars instead of nuts and bolts. So no tools are actually required to do your regular unpacking process. So how you do this is the bottom plate is in the main tube. The frame, you can use your pendant to lower the frame down so that the bottom plate's on the ground. You lift the eye bars up. You press the frame goes up, the bottom plate stays on the ground. And then the bottom plate can be wheeled away because it already has a built-in stand. And it also comes with a resin catching tub. I like to say it's like the Indiana Jones scene where he swaps out the treasure with a grain of sand or whatever that was. So you take the bottom plate out, and then the tub comes in. It's got a little splicing plate, so anything that's falling out falls onto the plate. So when you're unpacking and you're pressing all that packed cake or resin out, it falls into the tub, making it a easy and clean disassembly process. And how this is helpful is no matter what size of column you're using with the DAC ergo design, it takes about the same time to unpack a, let's say 30 centimeter column that it does to 120 centimeter column. Whereas on the smaller columns, on the older designs, it may take, an hour or two to do it on a small column, and then maybe a couple people a better half of a day to do. This takes one person maybe 10 minutes to do, no matter what the size. So big savings on time there. And you don't have to be underneath anything. It's ergonomic, so you can be standing the whole time, and you don't need to be underneath any heavy parts. So it's a lot safer. The reassembly of the DAC ergo is pretty much the same thing that I just said, but in opposite order. No tools or bolts are required. What you just do is the bottom plate swings back in. There's a little stopping indicator on the front and the back. You just push it back in, Once it hits that, you're in the correct position. You lower the column back down. You put the eye bars back in place, and then you're ready to go again. So that takes, again, another 5 or 10 minutes to do instead of the usual couple hours to a couple days. And recently, we also came up with the ACS Ergo. So this is similar to the DAC Ergo. It actually takes our SCS columns and then our DAC Ergo columns and kind of mates them together. ACS stands for axial compression synthesis. So this is the oligonucleotide synthesis column. This one has 2 main tubes that split apart. The bottom would be the process chamber. The top is the hydraulic chamber. So it's completely separated. And again, no tools are needed. If you look at this, there's eye bars holding the top and the lower main tube together. There's no repetitive motion of taking bolts on and off, no awkward positioning to be underneath the columns to do things. And the ACS Ergo also comes here with a gear reduction rotation mechanism. So the whole column or the bottom part of the column can be rotated using this. And it has the benefit of the DAC column with the piston that can be actuated up and down. So it's easy movement of the piston without having to use, nuts and bolts and trying to tighten it down to move the top plate up or down. So the unpacking for the ACS Ergo column is very simple. All you need to do is you lift up all the eye bars, you hook a hoist up to the top, and you hoist it out and away. You don't need to be super careful on it. It's built in and designed to be so that it's easy to use. So you just hook a crane up to it, pull it away, do your maintenance on the rest of it, and you can actually pull it back and plop it back into place. So it's quick unpacking. You can also use a resin catching tub for this. If you look between the column, there's a space that you can put a cart underneath and use the hand crank to tip the bottom main tube over to pour it out instead of having to scoop everything out. And you don't have to be, underneath any heavy parts, easily unpacking it. And then reassembly, like I said, again, no tools required. Ergonomic positioning, you just take a crane, you put it back into place. There's some guide pins that are there, so you can't really screw it up. And you just plop it back into place, put the eye bars in place, and you are now ready to go again. So those are the columns and how it makes it, faster turnaround and safer and more ergonomic for the operators. One thing I touched on at the start is one of the first things you do is packing the column, and that's what the slurry prep system helps with. With the slurry prep system, it's, as the name entails, it preps slurry. What slurry is the media or the solid support that you're using, mostly for the chromatography process. Either if you have it in, powdered format or semi-liquidous format, you pour that into the slurry prep system, you add your extra liquid, and this has a built-in agitator, air-actuated agitator. So no manual mixing is required. It mixes it up. You just turn the knob, and it will mix everything up, the slurry up perfectly for you. One thing that I didn't discuss is the defining. For those of you who don't know what defining is when resin comes to you, the manufacturer often guarantees that it's, let's say 40 micron in size, but everything's on a bell curve, So most of it is at 40 micron, but there's some things that are larger and some things that are smaller. And the fine particles in it can actually cause clogging of the frits inside of the column and decrease the efficiency of the packed bed. So what we recommend is defining, as in taking those fines out. And how we do that is by mixing up the mixture, letting it settle for a little bit until you see a separation. So actually your media will fall out of suspension but the fine particles will oftentimes stay in suspension. And in the column, there is a dip tube and a sight glass on the side. And what you can do is you can put that down to where the fine particles are, suck that all out, put new liquid back in, and mix it back up. And do this as many times as you need. I often refer to this as washing my rice before cooking. If you've ever done that, you mix your rice up and it's cloudy liquid. You pour the cloudy liquid out. You put some more water back in. You do that as many times as you want until your water runs clear and you know you have your perfect rice without all that extra fine particles of starch. So this helps with that. And then the last thing that this is helpful for is charging into the column. Instead of having to pour it, manually lift it up and pour it into the column, it just pumps it straight into the column. And not only is this safer, but also it's a lot faster, and actually speed is very crucial when charging a column, because if you're pouring it in, you're pouring multiple jugs into a column for, let's say, a larger column, then by the time you're at the last pour, the first pour might have started to settle a little bit, and settling results in a not evenly packed bed. So what the slurry prep system will do is it'll pump it in within 30 seconds or so, and then so you can pack your column right away while everything is still suspended. So all these Asahi products will help with speed, efficiency, a lot less manual, and then it's a lot easier for training new operators, and you don't need to be as mechanically inclined to use these. So going forward in the future, we'll see faster batch turnovers with this equipment, safer and easier processes, making more intuitive operation and maintenance, and reduce operator errors, which causes in other large downtime. And all that goes back in a circle because that reduces the time again to between turnover. And for you guys who are watching, what is your next steps? If you want to learn more about Asahi Kasei, we got a website, or you can contact Asahi Kasei Bioprocess for more information or some demos. You can explore upcoming webinars or past sessions to get more information. And if you thought that any of the equipment that I talked about today seemed interesting to you, you can request a quote for this equipment. Any questions?
All right, Liam, this was great. A great presentation, tons of insights into, kind of everything you guys are doing. It's awesome to see everything that's going on. And I've got a lot of questions coming in, so we definitely are going to get to those. Audience members, if you have more questions, please submit them through the Q&A on your screen. We're going to get to some now. Any that we don't get to, I'll pass along to Liam here for some potential follow-up after the event. You could submit those through the Q&A box. And then you can also reach out to him directly. There's a little blue circle on the right side of your screen next to his bio. Click on that blue circle. It'll let you send him a direct message. And you can contact him if you need any more information, and he can get you in touch with the right people if you want a quote or anything like that. So with that, let's get into this Q&A. So this first one coming in from David. So what prevents customers from utilizing this technology, the technology you talked about? Have there been any barriers or challenges to overcome that you've seen?
Yeah. I can think of two major challenges or barriers. One of them is obviously cost. With the new technology, there's more components, more cost to it. And then the second one would be resistance to change. So talk a little bit more about the first one. The cost, there's a little more initial upfront costs with the columns, which some people might be hesitant to, if they're used to this cost, and then they see something that's a little more expensive. People are hesitant to change over to it. But as I was stating, the initial cost may be a little bit higher, but the long-term cost of, reduced time spent during turnover, the man hours spent during turnover, the more efficiency you can gain, how many more batches a year can you do because you don't have to waste a couple of days in between each batch. I think that will make up for it. But, some people, it's harder to see that long-term vision instead of just the sticker price in front of you. And the other one is the resistance to change. So I know in a lot of pharmaceutical companies, they have their standard SOPs that are written down. They're sort of in stone. They can change, but it takes a lot of effort to change SOPs. So a lot of people will say, give me the same exact thing you gave me last time, so that we can use the same SOPs, which is understandable. People are used to a certain thing. But with the new systems is a lot easier to use, but there is, obviously there is resistance to some change.
Yeah, perfect. Thanks, Liam. Let's see. So I've got another one here. This one from Kian. So now that you are not using bolts, can these columns still be ASME rated? And what other area classifications or compliance standards would apply to this?
Yeah, sure. Yep. So these columns are still ASME rated for, the people in the United States, for people in Europe, PED Pressure Equipment Directive. It's PED rated as well. Another thing people ask about is ATEX certificates. And when I was talking about this, so I don't know if you noticed, but none of it is electrical components. It's all either hydraulics or pneumatics, which makes it very easy to classify in the ATEX rooms, and no electricity to allow for sparks.
Yeah, perfect. Thanks, Liam. Let's see. So this one here from Hannah. So I guess almost a follow up from our first question. Do you have any examples that you can share on efficiency gains after implementing some of these solutions?
I don't have exact numbers. I only have some, kind of qualitative things from some of my customers that I've dealt with. Some of the customers who were early adopters of this just keep on buying more and more of these columns. So we're doing something right there. And I talking to them, they say it's a lot easier. There's, like I said, there's one person versus maybe 3 or 4 people operating it, taking 10, 15 minutes instead of a couple hours or days, depending on that. So the efficiency, I don't have exact numbers, but I do, have some qualitative talking to some of our customers.
Yeah, perfect. Thanks, Liam. Let's see another one here. So, are there any plans or considerations integrating like automation or digital monitoring into these systems? They said for further efficiency or maybe safety improvements going forward.
Yeah. So currently, as a standard, we're probably not going to move towards much automation, because the automation actually happens in the like synthesis or chromatography skids. So these would be, packed and then wheeled into the suites, and all the automation will happen on the chromatography or synthesis skids themselves. So you could call these, like dumb columns. But a lot of times that makes things easier without having to worry about software failures for that, different classification for electrical equipment. We have had some automated bed height adjustment in our synthesis columns. So it's something we can do. People wanted to have the bed heights change as the solid support swelled and shrunk to reduce on excess buffer solution or cleaning solution. But as of now, most of this will not be automated, just because of how simple it already is. And so keep it simple, right?
Yep, yep. No, that's perfect. Yeah, thanks, Liam. Let's see. I've got maybe 2 more we can get to here. This one from Taylor. So, how do these solutions impact long-term maintenance requirements and maybe total cost of ownership compared to like a traditional system? Specifically, they mentioned, is there any difference in seal O-ring maintenance in the ergo style columns?
So for the most part, the ergo style columns have all the same seals. There's one extra little glide ring, but that's It's not process contact, not pressure holding. Very, very little maintenance to be done on that. So the cost of the seals and the O-rings is comparable, pretty much the same as the old columns. Now, the ACS Ergo column is slightly different from the SCS column, but it'd be the same cost of ownership as our standard dynamic columns. That's just for the physical O-rings. But like I was saying before, oftentimes people look at the numbers on the quotes, but then they don't think about the future. So this will also save time. So I guess in the long run, maintenance will, be cheaper, maybe not in components, but definitely in man hours and turnover speed.
All right. Beautiful. Well, thanks, Liam. I think this is going to be a great place to wrap up for us. And so, again, we want to thank you so much for being here, Liam Takahashi. Great presentation. A lot of really awesome, innovative stuff coming out of Asahi Kasai. And so we appreciate you being here and showing us everything. And so, audience members, also thank you so much for joining us today. Appreciate you being here. If we didn't get to your question, I'll pass those along to the team for a follow-up after the event. And with that, we hope you all have a great rest of your day, and we'll see you next time. Bye, everybody.
Thank you.